Hello and welcome to week 2 of the Bridge Math program. I hope that everything went well for you last week, looking through the packets where you were working on some whole numbers and decimal operations. This week we're going to look at some basic exponents and then also order of operations problems. So recall that what we're doing at this point is just reviewing some foundational material that will help you as you move into the college level classes. So let's look at some of the assignments that you had from last week. Be sure you've got everything there, and then we'll look at the upcoming material. I'm going to go ahead and close this so I can make the other camera larger. Bear with me just a moment here. Hopefully you'll be able to see that a little bit better. And then I know that these were pretty small. You should have this packet. It says Decimal Concepts Week 1. And if you recall on this packet, you would go through and when you came to different questions, you could just answer these questions as you work through the packet. So hopefully that worked well for you. There was also a second packet that says decimal packet number 2. That one was marked a little bit better. Same thing. As you read through here, you should be able to, look at these questions, answer the questions as you're going along with decimal operations, and then also you would have a key. This double-sided packet 1 answers are on one side and packet 2 answers are on the other. So that would give you all the answers to those problems in the packets. Now I hope that those were all correct. If you had any questions about any of those, be sure to let me know, and I will be glad to review and get back with you on that. Another thing that you had from last week was the double-sided sort of review packet that has the quiz sort of question and answer that you'll fill in. So you'll be able to know whether you got it right based on if this makes sense or not. And it's not necessarily funny, but at least it's going to make sense. What did the boy rodent say to the girl rodent? So your answer is going to be here, and then you'll have the other side as well. Let's just take a moment just to be sure. I know that sometimes the directions on these things can be a little confusing. So let's just look at one of these just as an example, and also to review place value for a moment to make sure that everybody's on the same page. Let's just do this first one here, 1, 2, 3. So it says, we're going to find an answer, and then whatever the answer is up here, we're going to put O in this case in that box. So start with a digit in the tenths place. So recall when you're talking about decimal numbers that if it has that THS, whether it's tenths, hundredths, thousandths, and so forth, that the THS is going to indicate that it is to the right of the decimal point or behind the decimal point. Okay, so the digit in the tenths place, that's the first one out. Okay, so that's going to be a 4. Add the digit in the tens place. So let's look at the digit in the tens place. Okay, so on the left-hand side of the decimal, we have ones, tens. There's not any things that, there's not a place called once with a THS, but there is ones, tens. So the digit in the tens place is 8. Okay, so it says I'm supposed to add those two numbers. So now I'm at 12. I'm just going to go here to the side and do that. You can sort of write this. How you put things in the blanks, just whatever's best for you to keep up with it is fine with me. Okay, then multiply by the digit in the 10,000ths place. So again, we have that THS, so we're on that right side or behind the decimal. Again, we have tenths, hundredths, thousandths, 10,000ths. So I'm going to be multiplying 12 by 5. Okay, and 12 times 5 is 60. So that's the number I'm looking for up here. And I'm going to put this letter in that box. So I found 60, and I'm going to put an O right there. Okay, so that's how you complete that. If you had trouble with that, that's how that's going to go. On the other side of this packet, What did Orgo's mother tell him to do with the seat belt? Okay. Let's just be sure that we're okay with the directions over here as well. So looking at, you see the page, they've broken it up into quadrants. So looking at just this top quadrant, the answers that you pick from are the answers to these. So there are more answers to select from than there are problems. So not all of these are correct. Okay, let's try just number 7. This is 8.376 to the nearest tenth. Okay, to the nearest tenth, we've got to figure out what's in the tenth spot. Well, that would be the 3. So this is either going to be 8.3 or 8.4. And the more proper way to say that would be 8 3/10 or 8 4/10. So which is this closer to? Okay, so this is 376. Is that, you can think about that if you want to fill in all the decimal places. Is that closer to 300 or is that closer to 400? Think about it that way. So it's closer to 3 or 4. Well, the way you make that determination is look at the number in the position to the right of the 3. That's a 7. If that number's 5 or higher, you're going to round up. If it's 0 to 4, you're going to keep it the same. Okay, but you can only pick between keeping it the same and rounding up. You can't go up 2 places or something like that. So 3 or 4. This is going to be closer to 8 4/10 because that, again, 7 is higher than 5. So we're going to bump that up. Okay, that's going to match this D right here. You can see there's some things that are close. There's an 8.2, there's an 8.0, but 8.4 is our answer. And so that means I'm going to take the D and put it in number 7 down here. Okay, so these aren't in order, 1, 2, 3, 4, 5. So number 7 matched with D, and so we're going to put a D in slot 7. So that's how that'll go. Hopefully you were able to get through that just fine. Keep in mind that we're not going to collect those right now. That's just something that, you have all the answers to these, and so you can check your answers. Let's see if I can pull this back up. Okay. You'll be able to check your answers, and you don't have to turn anything in from last week to be submitted. The only thing that was submitted was that pre-assessment. So now this week, what you're going to be working on is the packet 1.9, and you won't have to submit that either. Okay. You've got a couple of other things hanging out there from the work booklet. Let me make this a little smaller. Okay, from this work booklet, the CEI booklet, we were supposed to do pages 8 and 9, and then pages 14 and 15. So again, any questions you have on these, be sure that that gets passed along so that I'll be able to address that. I can make a video or something for that, for Thursday. So this was just numerical operations with whole numbers on page 8, and then page 9, similar thing. And then pages 14 and 15 should be also a review of the decimal operations that you looked at in your packets. Okay, so hopefully you work through the packets first, and then we're able to do some of these decimals and rounding problems on page 14 and 15. But remember, the packet has answers within it, so look for that answer page, and you'll be able to check your solutions there. Okay. One more thing that you had before we go to the new material is you had a keywords and phrases for math operations page. You may want to have that out because we're going to work with that as we go through the new material. Now, this at the top is really just to help you as you work through any of these sections, just to remember some of the key words that you may not have used in a while. For example, like difference means to subtract, product means to multiply. So those types of things are just helpful for you. And then on here also you will see division properties of 0 and order of operations. Both of those things we're going to talk a little bit more about, so you may find that you might want to make some notes on this page or just have some blank paper to make some notes on as well. What you're going to want to have out at this point is your packet that says week 2, and it's going to be 1.9 is the section at the top. So this is what we're going to be working on. And in this first video, what we're going to do is we're going to look at a few examples with exponents and square roots, and then we're going to look at dividing by 0 and see how that's going to go. And then in the next video, we'll do some order of operations problems. Okay, so let's just start out by looking at exponents. Now, I mean, certainly you can make some notes on here if you need to. You may not need to do this. Some of you are going to be much more familiar with these topics than others. So just whatever's your comfort level. I want to jot down examples. There are examples on the page as well. And remember that we did, we have, your books are electronic, so that's why it says the not for distribution on here when we print off the printed page. So I apologize that this is kind of in the way a little bit. But let's just review this. I'm going to go ahead and, since you have this example on your paper, we're going to start with that. See if that will, sorry, sometimes if I move this, it doesn't want to focus very well. If I can get this a little bigger. Not really. Okay, so hopefully you can see that on the paper in front of you. Okay, so when we look at exponents, we need to know the vocabulary. That's very important. Anytime you're working with math, you want to know, the language that what you're speaking about, not just doing the calculation. But here, this is 3 to the 5th power. Okay, you need to know that the large number is called the base, and the raised number is called the exponent. For now, we're going to work with all positive bases. We'll get to some negative numbers, and then eventually you'll get to negative exponents, but not in the bridge course, really. So this is a base and an exponent. Keep in mind that you will never multiply the base times the exponent. Okay, this is not going to be 15. We don't say 3 times 5. What exponential notation is it's really just a shorthand. That keeps us from having to write out so many multiplied factors. You can see over here. 3 to the 5th power really means 3 multiplied to itself 5 times. So instead of having to write out 3 times 3 times 3 times 3 times 3, this is the shorthand way that we can collapse it into this 3 to the 5th. Okay, so that just makes it more streamlined, easier, especially when we're dealing with multiple numbers raised to powers. Okay, so that's what this notation means. So for example, I'll just go over here. If you had 2 to the 3rd, okay, that would be 2 times 2 times 2. I write 2 out multiplied to itself 3 times. The exponent tells me how many 2's to write. We do not say 2 times 3 is 6. Check this answer. It's not 6. Okay, 2 times 2 is 4. Times 2 is 8, not 6. Okay, so 2 to the 3rd is 8. So just be careful and be sure that you're not multiplying that base times the exponent. Okay, I'm going to get a clean sheet of paper. And then let's look at just a few other examples. They mentioned this in the box there in the middle of your page. There's some more vocabulary where they talk about 5 to the 2nd power. Okay, the way that we read that is 5 squared. Okay, squared. And anytime you have an exponent 2, you'll often hear it referred to as squared. Now it's fine to say 5 to the 2nd power, that's correct, but typically you'll hear 5 squared if it's to the 2nd power. Likewise, if you have an exponent 3, that is referred to as cubed. So you'll hear that when an exponent is 3, we say something is cubed. Okay, doesn't matter what the base is. The 5 is just an example. Okay, but now if your exponent is higher than that, so let's say you had 5 to the 4th, or 5 to the 7th, or 5 to the 12th. Okay, just different exponents that aren't 2 and 3. Then you just address the exponent by what the number is. So you would say this is 5 to the 4th power. 5 to the 4th power. This will be 5 to the 7th power. That really is spelled correctly on that 4th. Sorry, I just sort of ran all that together. 5 to the 4th power, 5 to the 7th power, 5 to the 12th power, and so forth. Okay, these 2 and 3 are the only ones that have special names, squared and cubed. Another thing to recall is if we want to raise something to the 1st power. So if we had 5 to the 1st power, that's just how I would say it. 5 to the 1st power, because the exponent's 1. But you almost never see an exponent 1. It's just sort of understood to be there. So 5 to the 1st power is just 5. Okay, we usually do not write the 1. It's just there. Okay, so if you see a number without an exponent, it means it's to the 1st power. So that's something there. And another rule that's not listed on this page, I don't believe, is what happens when we raise something to the 0 power. That's another rule. Any number to the 0 power is 1. So you could have, 20 to the 0 power, 100 to the 0 power, that's 1. But we're not going to see those in the homework for this section. But we will see things to the 1st power. Anything to the 1st power is just the number itself. Okay. All right. So now let's look at the opposite of that, which instead of raising something to the 2nd power would be taking a square root. So square root is really the opposite operation of squaring something. Okay. So this is this symbol is a radical symbol, or it can be called a radicand. What's underneath here is called the radicand. This is a radical sign, radical symbol. It just means square root. Okay, so if I said the square root of 4, then what you're asking yourself is what number multiplied to itself gives me 4. So it turns out 2 times 2 is 4. Or another way to say that would be 2 to the 2nd power is 4. So what that means is, working backwards, the square root of 4 is 2. Okay, what number times itself gives me 4? 2. So that means the square root of 4 is 2. Let's try another one. How about the square root of 9? What number times itself gives me 9? Okay, so 3 times 3 is 9. So that means that the square root of 9 is 3. So you can see that this is just sort of working backwards. 3 to the 2nd power equals 9. So the square root of 9 would be 3. Okay, try another one. Square root 49. What number times itself gives me 49? Well, 7 times 7 is 49. So that means the square root of 49 is 7. What if we have square root of 0? What number times itself gives me 0? Well, 0 times 0 is still 0. So the square root of 0 is 0. Okay. While we're on 0, let's look at the definition here of division and how we divide by 0, or we can't divide by 0. What happens when we have 0 and division? So I'm just going to put up an example. Six divided by 2 equals 3. Okay, this is a fact. We know this. Okay, 6 divided by 2 equals 3. Well, what does that have to do with 0? You may wonder. Let's just look at the rule for division and see how this goes. Division is the opposite operation of multiplication, and it's actually defined by multiplication. So we say that 6 divided by 2 equals 3 if 2 times 3 equals 6. Well, that's true. Okay, so we know that 6 divided by 2 equals 3. Number one, 3 is a unique answer. Okay, there's no other number. When I do 6 divided by 2, there's no other outcome. It's always 3. But looking at the multiplication part of it, when I take these two numbers, 2 times 3, I get my 6 back. So that's how I know that works. Division is defined by multiplication. Let's try another one. Let's do 20 divided by 5 equals 4. Okay, that's true. 20 divided by 5 is 4. We'll check that with multiplication. 5 times 4 is 20. Sure, that works. Now, what happens though if we have 0? So let's just do, let's say 10 divided by 0 equals, we don't know. We don't know what 10 divided by 0 is. I'm just going to call it x, okay, just for the purpose of this example. So let's match this pattern over here. If this division is true, then this multiplication must be true. So matching this pattern, it would have to be the case that 0 times x equals 10. But what is 0 times anything? 0 times any number is 0. So this can't work. I can't say 0 times something, x or whatever it is, and get 10. 0 times anything is 0, not 10. So this doesn't work. Okay? So trying to divide by 0 breaks the definition of this division. So that's why we say when we divide by 0, it's just undefined. It does not fit the definition, undefined. Okay? Whereas these up here are defined. This is undefined. We don't know. There's no definition for this. Okay? So it's not a numerical answer. We just say it's undefined. You can't divide by 0. But this is why, because it breaks the definition of division. Now, you could have 0 in front. You can say 0 divided by, say, 10. Okay? 0 divided by anything is 0. If I have nothing and I cut it into 10 pieces, it's still nothing. Okay? So 0 divided by, 0 cut up into pieces is still 0. Whereas 10 divided by 0 is undefined. So just know that difference. If you were looking at in fraction form, if 0 is under that fraction line, well, that is undefined. Okay, under the line is undefined. Whereas if 0 were in the numerator of the fraction, 0 divided by 5, that's just another way to say it, that would be 0. Okay, so just one of those things that's going to come up as we do the order of operations and we work throughout the rest of the sections. Okay, so what I'm going to do at this point is stop the video, and then when we come back, we will look at some examples using the order of operations. So we'll start that in the next video.